All right, hello everyone. We're proceeding along to section 5.4 today. We have a mere 3, 4, 5, 6 examples to go through, and I think you'll like this. It's about simplifying complex rational expressions. So let's get right into it as far as what a complex fraction is. First of all, we'll start with practice problem 1. All right, so here's our first example. And this is a complex fraction. It's a fraction divided by a fraction. All right, so as I was saying, I had to answer a text message here. I've got complex fraction is a fraction divided by a fraction, and that's what fractions are, division problems, really. If you think about it, if I had something like 4 over 2, well, we know that simplifies to be 2, but even the way we say it, 4, the fraction bar means divided by 2. If I wrote it horizontally, the numerator would be 4, and then I'd say divided by the denominator, which is 2. So 4 divided by 2, of course, is 2. All right, and that's important to note when we're doing when we're getting into the complex rational expressions. All right, keep that in mind, which is which. What is the numerator? What is the denominator? Okay, so what we're going to do with this is to write this as 1/3 divided by 3/4. And now I can go back and do the keep, change, flip thing that we learned in a previous section. So it's keep the first fraction, 1/3, change the sign from division to multiplication, and then do the reciprocal of 3 over 4. And that's 4 over 3. And that's what we get the word flip from. Okay, before I multiply, I want to do any canceling that I can, make the multiplication a little bit easier. I cannot, so I'm just going to multiply numerator times numerator and denominator times denominator. And so that's it. Okay, now we'll go about doing them with rational expressions. Rational meaning with variables in it. Okay, let's go ahead. Okay, so here it is. It looks complicated, right? I mean, it's like, oh my God, this problem's huge. But I like to break it down into 2 smaller problems, okay, which means I'm going to subtract the numerators. 1 over x minus 1 over y. And when I do that, my way of teaching this is to get the numerators to be the same. And so I'm going to multiply the x here by y. And what I do to the bottom, I do to the top. You heard me say that before, and I guess I'll continue to say it. All right, so now my goal will be to get the y to be equal to y times x. So I need an x in this other denominator, and what I do to the bottom, I still do to the top. All right, so the big part there is I've got my denominators to be the same, and they're just going to be xy. Because y times x equals xy, and y times x here is xy. You can flip them. It's the commutative property of multiplication from 3rd grade. All right, now we'll go about doing our numerators. So this is just simply y times 1 is y, minus, and my minus sign comes from the problem itself because it's subtraction, minus what? 1 times x, which is x. So I'll write my numerator up here as part of my solution for the numerator to be y minus x. All right, so that's done. Now I'm going to continue my fraction bar over here, and that's over this fraction in the denominator of 1 over y plus 1 over x. So it's the same thing, get the denominators to be the same. This y I'm going to multiply by x, top and bottom. And this x I'm going to multiply by y, top and bottom. And again, what we're going to have, another fraction bar here. My denominator is xy, and my numerator in the denominator is going to be x times 1 is x, plus 1 times y is y. All right, so this is where I'm at thus far. Add my equal sign there. Now I'm going to do the keep, change, flip. Slide this over. I'm going to do this one time here. I'm going to write it in order. It's y minus x over xy divided by x plus y divided by xy. Okay, I took an extra step there. I didn't need to do that. Now at this point, I just copied what I had, so that was silly. All right, so now I'm going to do the horizontal way. All right, so that's going to be, this is my numerator, so that's going to go first, y minus x over xy divided by the denominator, which is x plus y over xy. Okay, now this is where I wanted to be. I did an extra step there, and I avoid extra steps. It's a lot of writing, and I want to do a lot of writing. Neither I don't want you to do a lot of writing. All right, so now we'll do the keep, change, flip. Y minus x over xy times keep, change, flip. So I'm going to flip the second fraction, xy, and that's going to be over x plus y. All right, that's much better. Now we do our canceling before we multiply everything over. So I got an xy here and an xy here. They turn into ones. And that's all I can do. So I'm going to bring over the y minus x, and that's going to be over x plus y. And remember again, you cannot cancel these y's or these x's because they're part of an addend. An addend being addition and subtraction problems. We can only cancel factors. Okay. All right, so that is the practice problem 2. All right, here is practice problem 3, where it says, let f of x equal x minus 1 divided by x squared minus 16, and g of x equals x squared minus 1 over x plus 4, and they want us to simplify f of x over g of x. So we'll just substitute f of x for g of x. All right, we know what they are. So I'm going to have f of x is x minus 1. I'll do it over here. X minus 1 over x squared minus 16. And that's going to be divided by g of x. And g of x is x squared minus 1 over x plus 4. All right, there's my complex fraction, my complex rational expression. Okay, and here is where we're at thus far. Just the beginning, I just replaced the expressions for f of x and g of x, and now I can do the keep, change, flip now. All right, and just to shorten our work so we don't do a lot of writing, if you're with me on this, this would be x minus 1 over the x squared minus 16 divided by x squared minus 1 over x plus 4. Okay, and now how about we do our keep, change, flip. Let's scroll this up. Keep the first fraction. Change the sign from multiplication to from division to multiplication, and flip the second fraction. Okay, and now I've got some factoring to do. When I see these these quadratics here, these quadratic expressions, I can factor those. And if I do that, what will I have? Let's do x squared minus 16. That's a difference of two squares. So I'm going to set up my parentheses here and factor it. So I got x and x, minus and plus, and then how about 4 and 4? So that means this is gone. The x squared minus 1, that's a difference of two squares. So the same thing's going to come along here, where I have x and x, minus and plus. How about 1 and 1? And this is gone now. And before I multiply all this across, I want to do my canceling. So here I've got an x minus 1, and here's an x minus 1. So that over each other become 1s. And on this side here, I got an x plus 4, which is going to be a 1, and this x plus 4 would be 1. Okay, everything's canceled that I could possibly do. Now I'm going to multiply my numerators. 1 times 1 is 1. X minus 4 times x plus 1. We don't multiply these together, just leave them factored. X minus 4, and this is x plus 1. And there you go. Done. It's kind of fun, really. I say that a lot. I enjoy math. It's just so interesting to me. Okay. How about let's go on to our next one, example or practice problem 4. All right, check out practice problem 4 here. Here's my numerator denominator. Let's start with the numerator. I want to subtract these two. 1 minus 9 over x squared. That is a 9. All right, so get our denominators to be the same. So I'm going to, this is really 1 over 1. So I'm going to multiply the 1 times the x squared here, top and bottom. All right, that's not bad. And over here, I've got a fraction bar. I know now my denominator is going to be x squared. And my numerator is going to be x squared times 1, which is x squared, minus the 9. All right, so that's my numerator. All right, now we'll do the denominator. Same thing. Get our denominators to be the same. I'll write that as 1 over 1. Bye. And we want to get them all to be the same. So this x, I got to multiply. I want to get it to equal x squared. So I got to multiply top and bottom by x. Okay. This 1, I'm going to multiply by x squared, top and bottom. Bingo. All right, so as I move this across, I know my denominator is x squared, and my numerator is going to be x squared times 1 is x squared, minus 5x plus 6, and that worked out quite nicely. And now we'll do the keep, change, flip. And now I'll show you a little shortcut to do. I think we're ready. I'll slide this over, and this, I already wrote the x squared minus 9 over x squared, so I know if I'm doing the keep, I'm keeping the numerator, changing the sign to multiplication, and then I'm going to flip the denominator. So that's going to be x squared divided by this x squared minus 5x plus 6. All right, so this is the problem now at this point. So this is gone. I flipped it and brought it up over here. Okay, and now we've got to do some factoring. So drop this down here. So I'm going to have x squared minus 9, which is going to be, when I factor it anyway, what's it going to be? I got x minus plus 3 and 3. Gone. Okay. And this trinomial here I'm going to factor. It's an easy one because the lead coefficient is 1. And I'm going to have x minus a negative times another negative would be the positive here. Negative times negative is positive. And then my two numbers, it looks like it's going to be 3 and 2. All right, and looking pretty lovely. Now, for the sake of discussion here, I'm going to rewrite everything where you wouldn't have to as long as you know where everything is there. This is gone now. So really what I've got here is what? X minus, I'll rewrite the whole thing. X minus 3 times x plus 3 over x squared times x squared over here over x minus 3 times x minus 2. This is where we're at when we rewrite all that mess. And let's do some canceling. X squares cancel out, become 1s. I've got an x minus 3 here and an x minus 3 here. So all I have left, you can see it, x plus 3, that's going to be over x minus 2. And that is the answer we're looking for that pretty tough problem. Yeah, I like that problem. That's not bad. All right, 4, and let's go to practice problem 5. All right, here is practice problem 5, and all I gotta say is wow. Wow. All right, let's try this out. What shall I do? I don't know if I'll be doing myself a great favor there, but let's try a couple of things we can do here. I'm going to try to get my denominators to be the same now. All right, so that means if I want to make this, there's really a 1 here, so I could multiply x plus 1 over 2 times 1. That would make my denominators to be the same, but then I also have to multiply it to x plus 1 over 2 on the top. All right, let's kind of give us some room here. All right, so what do we know? Thus far, I know my denominator is going to be x plus 1 over 2. Okay, and then I'm going to distribute the 4 to the x plus 1 over 2. So what will that give me? That will give me, I'm going to erase this, get it out of my way. And so that's going to give me 4 times x is 4x plus 4 times 1/2, which is 4 over 2, which is 2. 4 times 1 is 4, over 2 is 2. Okay, and that would be minus 2. So that's going to give me 4x. 4x plus 2 minus 2 is 4x. Okay, and then there's my like denominator of x plus 1 over 2. Now I'm going to come over here and I'm going to add together x plus 1 over 2. No distractions. Okay, so that means here there's really a 1 there again, so I'm going to multiply top and bottom by 2. So that means I'm going to end up with 4x over, let's see, what do I get here? My denominator is going to be 2, and then my numerator is going to be 2x. 2 times x is 2x plus 1. 2x plus 1. And now I'm going to do the keep, change, flip here. Okay, so that means I'm going to write this up as I'm going to write this 4x as 4x over 1 divided by 2x plus 1 over 2. Just kind of rearranging that to put my denominator. Now I can keep, change, flip. I'm keeping the first fraction, the 4x over 1, then multiplying it by the reciprocal of 2x plus 1 over 2. So that would be 2 over 2x plus 1. Okay, and what do I get? Okay, I got 4x times 2 is 8x, and that's going to be over 1 times 2x plus 1, which is 2x plus 1. I cannot factor anything out of these. Remember, that 2x plus 1 is part of an add-in, so I cannot simplify that. If I could factor something out of the denominator, then I would, but I really can't. So I'm going to leave this as my solution for that problem. Okay, that was mine. You could have done the original. When we go back to the original, I could have done the addition here, but that gave me what? 2x plus 1, and this is 2x plus 1. If you did it here, then you end up with the same thing. So try it out both ways. Sometimes you learn something more, a better way, and it works anyway, either way. All right, let's go on to the last one. Okay, here we are. Now they've introduced something else here, or brought it back, which is the negative exponent. Take a look at that. We have negative exponents to deal with now. All right, so my approach here is I want to get rid of those negative exponents and turn them positive. All right, and if you remember, I'm going to rewrite this numerator, and it's going to be 1. I'm going to change color too here. I'm going to use yellow maybe. How about 1 minus, and to turn that negative exponent positive, who remembers that? If I have x to the negative 1, this is just an example now. This equals 1 over x. So I remember teaching this to my students in the past, where we have the, this is really x negative 1 over 1. And so we're bringing down the negative exponent, x to the negative 1, bringing it from the numerator to the denominator, and it turns positive when we switch positions of these exponents. All right, so in other words, I'm going to have 1 minus 9, and in order to make this x negative 2 square, it's got to come into the denominator. So that would make it x squared. That's how I'm rewriting that. It's this equivalent expression. I leave the 9 alone. It's not, if it were enclosed in parentheses, then I'd bring it down in the denominator as well, but it's not. So it's just the x to the negative 2 that I want to turn positive. All right, and that's going to be all over the same thing I'm going to do in the denominator. So that means it's going to be 1 plus 2 over x to the first minus 8 over x squared. And that's how I turn those negative exponents positive. All right, now we've got a similar problem that we had previous in example 5. Not 5, it was 4. A similar problem. Let's get our denominators to be the same. So it's really 1 over 1. So I'm going to multiply top and bottom by x squared. And my denominators, we know what it is. So it's going to be x squared in the denominator, just bringing it over. And then I've got x squared times 1 is x squared minus 9. Oh, there's that difference of 2 squares, so you know you're going to be factoring that. But just kind of slow down and enjoy the ride. Enjoy the what we're figuring out here. All right, the same thing on the bottom. I've got to make everything x squared. This is 1 over 1. And the x I'm going to multiply top and bottom by x to make it x squared in the denominator. That's x here. And then the 1 I'm going to multiply by x squared, top and bottom. So all of this becomes, let's see, my denominator in the denominator is going to be x squared. My numerator is going to be x squared times 1 is x squared, plus 2 times x, which is 2x, minus 8. Okay, and here we are. Let's see, keep, change, flip. I can do it now or do it later. How about we do it now? Keep the first one. That's this already written. I don't have to rewrite it. And I'm going to change the sign to multiplication, and now I'm going to flip the bottom fraction. And that's going to be x squared over x squared plus 2x minus 8. All right, we're ready to go. This is gone now. Here, we flipped it and it's gone. So you can't do that as easily on paper, but you know, might as well have some fun here too. All right, so let's do our factoring now. The x squared minus 9, further that, get rid of that for our sake anyway. And I'm going to have 2 parentheses here. I've got x minus plus 3. This difference of 2 squares is gone. Then down here on the bottom, that's a factoring concern. So I've got x here, x plus and minus, because a positive times a negative is a negative. And what numbers do we want? 4, 2. 4 minus 2 is positive 2. 4 times negative 2 is negative 8. So it all checks out. All right, and this is it. So this is gone now as well. It's important to cancel those out so we don't get confused. I don't get confused anyway, because I'm easily confused. All right, so let's go. I'm going to have these two cancel out. X squared over x squared become 1s. And look what I have left now. X minus 3 times x plus 3. And x plus 4 times x minus 2. And unless I made some kind of a mistake here, did I write the wrong one down? No. Well, I did. I did. So this is supposed to be, I see what I did too. I took it from the example. I have a problem with that, as you notice. I wrote it as x squared minus 9. It should have been x squared, originally it was 1 minus 4x to the negative 2. I wrote it as 9. 1 minus 9x to the negative 2. In the practice problem, it's 1 minus 4x to the negative 2. But that's okay. I'm just going to leave it. It's still right. I just picked the wrong number. All right, so in this case here, I've got my final answer is going to be x minus 3 times x plus 3 divided by x plus 4 over x minus 2. And that would be my final answer for the problem that I made a mistake on when I copied it. All right. Just about the same, only the 4 and the 2. So I'll tell you what, leave the number 6 there for you to do, just as an extra practice problem. And don't look at the answer on the bottom of the page and see if you come up with the same answer. Okay, I'm comfortable leaving this because it's right. The process is the same. You'd have a further cancellation here of this answer, but nevertheless, it just so happens because of my error, I have no canceling going on at the end of the problem. All right, and that is it for today. If you have questions or anything, or you want to see how that is done, you can always let me know, and I'll be happy to do it, because I could do math all day. I just love it. Okay, thank you, and talk to you again for section 5.5.